An Ufer ground, also known as a concrete encased electrode, is a grounding electrode encased in concrete. To find illustrations of Ufer ground laying processes, you can explore several resources. Firstly, the National Electrical Manufacturers Association, or NEMA, provides technical drawings and specifications. Their website may offer visual aids demonstrating the installation process. Secondly, the IEE Power and Energy Society is a great resource. The IEE often publishes articles and papers on grounding systems, including Ufer grounds, which may contain helpful illustrations. The IEE Explore database is where you can find the documents. Thirdly, Electrical Engineering Stack Exchange is an online forum where engineers and electricians discuss various topics. Search for discussions related to Ufer grounding, as they may include user-submitted illustrations or links to external resources. There are some books and articles with diagrams and explanations. One book to look at is Electrical Wiring Commercial by Philip Traister, which may have diagrams of Ufer grounding systems in section 4.3.1. The National Electrical Code, specifically NFPA 70, provides code requirements and illustrations for Ufer grounds in section 250.52. This section outlines the specifications and visual examples for proper installation. Additionally, the IEE Guide for Design of Grounding Systems for Buildings and Other Structures, which is IEE Standard 80-2013, offers technical guidance and illustrative examples of Ufer grounding, and you can find relevant information in Chapter 10. Many manufacturers' websites provide brochures and technical documents on grounding systems, including Ufer grounds. The Copper Development Association, or CDA, is one such organization that may offer relevant materials. Look for step-by-step guides and illustrations for Ufer grounding installations on the Ground Fault Protection Systems International, or GFSI, website. Some organizations and manufacturers offer webinars or workshops that cover Ufer grounding systems and provide illustrative materials. These events often include visual demonstrations and presentations. If you require hands-on experience and visual demonstrations, consider contacting a licensed electrical contractor who specializes in grounding systems. They can provide on-site demonstrations and illustrations of the Ufer ground laying process. Ufer grounds are typically installed during the construction phase of a building. They involve encasing a length of steel rebar or copper conductor within the concrete foundation. The purpose of a Ufer ground is to provide a low-impedance path to earth, helping to protect against electrical faults and ensure safety. The NEC specifies the requirements for Ufer grounds, including the minimum size and length of the grounding electrode, as well as the depth at which it must be buried in the concrete. Section 250.52 of the NEC covers concrete encased electrodes. A Ufer ground must have at least 20 feet, or 6.1 meters, of bare copper conductor not smaller than number 4 American wire gauge, or AUG, or at least 20 feet of steel reinforcing bar or rod not less than 1/2 inch or 12.7 millimeters in diameter. It needs to be encased by at least 2 inches or 50.8 millimeters of concrete and located within or near the bottom of a concrete foundation or footing that is in direct contact with the earth. The concrete must be directly in contact with the earth. This ensures effective grounding. The conductor or bar must be electrically connected to the building's grounding system, which typically involves connecting it to the main grounding busbar or grounding electrode conductor. This connection ensures that any fault current is safely directed to the earth. Proper installation of a Ufer ground is critical for its effectiveness. The concrete must be of sufficient quality to provide good contact between the electrode and the earth. It is crucial to follow the NEC guidelines and local electrical codes to ensure compliance and safety. The Ufer ground serves as a primary grounding electrode, supplementing other grounding methods such as ground rods or ground plates. In many modern buildings, the Ufer ground is the primary grounding electrode due to its effectiveness and reliability. The low-impedance path to earth helps to quickly dissipate fault currents, reducing the risk of electrical shock and equipment damage. Regular inspection and testing of the grounding system are essential to ensure its continued effectiveness. Grounding electrode testing can verify the integrity of the Ufer ground and identify any potential issues. When installing a Ufer ground, it is important to coordinate with the concrete pour to ensure that the electrode is properly encased within the concrete. The electrode should be securely fastened to the rebar or formwork to prevent it from shifting during the pour. The concrete mix should be thoroughly vibrated to eliminate air pockets and ensure good contact with the electrode. After the concrete has cured, the electrical connections to the grounding system should be made. Use appropriate connectors and ensure that all connections are tight and corrosion resistant. Protect the connections from moisture and physical damage. Consider using a grounding compound to enhance the conductivity of the connections. In addition to the NEC requirements, it is important to follow any local electrical codes or regulations that may apply to Ufer ground installations. Local codes may have additional requirements or restrictions that must be followed. Consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes. Ufer grounds are particularly beneficial in areas with poor soil conductivity. The large surface area of the concrete encased electrode provides a more effective grounding path than traditional ground rods in dry or rocky soil. The concrete helps to retain moisture, improving the conductivity of the surrounding soil. In some cases, multiple Ufer grounds may be installed to further enhance the grounding system. This is often done in large buildings or facilities with critical electrical loads. The multiple electrodes provide redundancy and ensure that the grounding system remains effective even if one electrode fails. Ufer grounds are also used in conjunction with other grounding methods such as ground rings or counterpoise systems. These combined systems provide comprehensive grounding protection for the entire facility. A ground ring is a continuous loop of bare copper conductor buried around the perimeter of the building. A counterpoise system consists of a network of buried conductors extending outward from the building. Both of these systems help to reduce ground impedance and improve the effectiveness of the grounding system. When designing a grounding system, it is important to consider the specific characteristics of the site, including soil type, moisture content, and proximity to other utilities. A qualified electrical engineer can perform a soil resistivity test to determine the conductivity of the soil and recommend the appropriate grounding system design. The grounding system should be designed to meet the requirements of the NEC and any applicable local codes. Regular maintenance of the grounding system is essential to ensure its continued effectiveness. Inspect the grounding connections for corrosion or damage and repair or replace any damaged components. Periodically test the grounding resistance to verify that it is within acceptable limits. Keep records of all inspections and tests. The Ufer ground is an integral part of the building's electrical safety system. It provides a low impedance path to earth, helping to protect against electrical shock and equipment damage. Proper installation and maintenance of the Ufer ground are essential for ensuring the safety of the building and its occupants. Always follow the NEC guidelines and local electrical codes when installing or maintaining Ufer grounds. Consult with a qualified electrical contractor or engineer if you have any questions or concerns. Ufer grounds are a reliable and effective method of grounding electrical systems. They are widely used in commercial, industrial, and residential buildings. By understanding the principles of Ufer grounding and following the proper installation procedures, you can ensure the safety and reliability of your electrical system. One common misconception about Ufer grounds is that they are maintenance-free. While they do not require frequent maintenance, they should be inspected periodically to ensure that the connections are still secure and that there is no corrosion. Another misconception is that Ufer grounds are only necessary in areas with poor soil conductivity. While they are particularly beneficial in these areas, they are a good practice in all locations as they provide a reliable and effective grounding path. Ufer grounds are a valuable component of any electrical system and should be installed and maintained properly to ensure their effectiveness. They offer a safe and reliable means of grounding electrical systems, protecting against electrical shock and equipment damage. By following the NEC guidelines and consulting with qualified professionals, you can ensure that your Ufer ground is properly installed and maintained. The information available from NEMA, IEE, and other sources can provide further details and visual aids to assist in understanding the Ufer ground laying process. Always prioritize safety and consult with experienced professionals when working with electrical systems. The benefits of a properly installed Ufer ground are significant, contributing to the overall safety and reliability of the electrical infrastructure. The Ufer ground, when correctly implemented, serves as a cornerstone of electrical safety, offering a dependable path for fault currents to dissipate, thereby minimizing the risk of electrical hazards. In summary, finding visuals of Ufer ground laying processes involves exploring online resources like NEMA and IE, consulting books and articles, checking manufacturer websites, and attending industry events. Additionally, consider contacting an electrical contractor for hands-on demonstrations. Remember to follow the NEC and local codes for proper installation and maintenance. The Ufer ground is a critical component of electrical safety, ensuring a low impedance path to earth. Proper installation and regular inspection are essential for its effectiveness. The Ufer ground contributes significantly to the overall safety and reliability of electrical systems. It is an essential element in protecting against electrical shock and equipment damage. Understanding the principles of Ufer grounding and following the appropriate procedures are crucial for ensuring a safe and effective electrical system. Always consult with qualified professionals and adhere to the NEC and local codes when working with Ufer grounds or any other electrical components. The Ufer ground is a foundational aspect of electrical engineering, providing a robust grounding solution that enhances the safety and performance of electrical installations. Its proper implementation is a testament to sound engineering practices and a commitment to safety. The combination of online resources, books, manufacturer information, and expert consultations provides a comprehensive approach to understanding and implementing Ufer grounds effectively. This ensures that electrical systems are grounded reliably, safeguarding against potential hazards and promoting a safe electrical environment. The information available through these resources empowers individuals and organizations to make informed decisions and implement best practices in electrical grounding. This contributes to a higher standard of electrical safety and performance in buildings and structures of all types. The Ufer ground, with its inherent reliability and effectiveness, stands as a vital element in the pursuit of electrical safety and operational excellence. Its continued use and advancement are essential for maintaining a secure and efficient electrical infrastructure. In addition to the resources mentioned, consider exploring technical journals and publications related to electrical engineering and construction. These sources often contain detailed articles and case studies on Ufer grounding systems, providing valuable insights into real-world applications and best practices. Furthermore, networking with other electrical professionals can provide opportunities to learn from their experiences and gain practical knowledge about Ufer ground installations. Attending industry conferences and seminars can also be beneficial, as these events often feature presentations and workshops on grounding systems and other electrical topics. The knowledge and skills gained from these activities can enhance your understanding of Ufer grounds and improve your ability to implement them effectively. Remember that electrical work can be dangerous, and it is essential to follow safety precautions and consult with qualified professionals when working with electrical systems. Never attempt to install or maintain a Ufer ground without proper training and experience. The Ufer ground is a critical component of electrical safety, and it is important to ensure that it is installed and maintained correctly to protect against electrical hazards. The Ufer ground's effectiveness depends on several factors, including the size and type of electrode, the quality of the concrete, and the soil conditions. It is important to carefully consider these factors when designing and installing a Ufer ground to ensure that it meets the specific requirements of the site. In addition to providing a path for fault currents, the Ufer ground also helps to stabilize the voltage in the electrical system. This can improve the performance of sensitive electronic equipment and reduce the risk of electrical noise. The Ufer ground is a versatile grounding solution that can be used in a wide range of applications. It is particularly well suited for large buildings and facilities where a robust grounding system is required. The Ufer ground is a long-lasting and reliable grounding solution that requires minimal maintenance. It is a cost-effective way to protect against electrical hazards and ensure the safety of people and equipment. The Ufer ground is an essential element in any well-designed electrical system. It is a critical component of electrical safety and should be given careful consideration during the design and installation process. The resources and information provided in this response should help you find the illustrations and information you need to understand the Ufer ground laying process. Remember to always follow safety precautions and consult with qualified professionals when working with electrical systems. The Ufer ground is a key element in ensuring the safety and reliability of electrical installations, and its proper implementation is essential for protecting against electrical hazards. The Ufer ground represents a commitment to safety and excellence in electrical engineering, providing a robust grounding solution that enhances the performance and longevity of electrical systems. Its continued use and improvement are vital for maintaining a safe and efficient electrical infrastructure. In addition, understanding the regulatory requirements and industry standards related to Ufer grounds is essential for ensuring compliance and avoiding potential liabilities. Familiarize yourself with the relevant sections of the NEC and any applicable local codes, and stay up to date on any changes or updates to these regulations. Consult with experienced electrical professionals and participate in industry training programs to enhance your knowledge and skills in this area. By staying informed and engaged, you can ensure that your Ufer ground installations meet the highest standards of safety and quality. The Ufer ground is a testament to the ingenuity and innovation of electrical engineers, providing a reliable and effective solution for grounding electrical systems. Its continued development and application will play a crucial role in advancing the field of electrical safety and performance. The Ufer ground, with its inherent benefits and proven track record, remains a cornerstone of modern electrical engineering practice. Its proper implementation is a responsibility that should be taken seriously by all electrical professionals, as it directly impacts the safety and well-being of individuals and communities. The Ufer ground is an investment in safety, reliability, and peace of mind, providing a robust grounding solution that protects against electrical hazards and ensures the long-term performance of electrical systems. Its continued use and advancement are essential for creating a safer and more sustainable electrical infrastructure.